Okay, so today we are going to be going over time with our first grade class. And our I can statement is, I can tell time to the hour and half hour using set and linear models. So we are going to look at our question for today, and it says, the party starts at 1:30 p.m. and ends at 5 o'clock p.m. How long did the party last? So we're going to use our Make 60 approach with our time tracker and our clock to help us figure out how long the party lasted. So looking back at our problem, our problem, it says that the party started at 1:30. So here we're going to have our start time. So it said it started at 1:30 and we're going to put our start. And our clock is already set to 1:30. So looking at our clock, if we're at 1:30, to get to the next nearest hour, which would be 2 o'clock, we're going to move from 1:30 to 2 o'clock, and we moved 30 minutes. And we know that we moved only 30 minutes because we went half of the clock. And we know that 1 hour is the full clock, which is 60 minutes. And we know that half an hour is half the clock, which is 30 minutes. So now we're going to look at our time tracker, and we are now at 2 o'clock. And if we started at 1:30, we said that we went half of the clock, so we moved 30 minutes. So over here in our time tracker, we're going to write 30 minutes. Okay, now that we're at 2 o'clock, let's look back at our question, and it says that it ends at 5. So we're just at 2 o'clock. So we're going to make a complete hour to get us to 3 o'clock. So we're going to go around the entire clock, and we know that the entire clock is 60 minutes, which is 1 hour. So now we're at 3 p.m. So we're going to go back to our time tracker, and we're going to write 3 o'clock because that is what time we're at now. So from us going from 2 all the way to 3, we know that we did a complete circle, which gives us 1 full hour. Okay, and remember, we're going to 5 o'clock p.m. So we're only at 3. So we're going to move 1 more full hour, and we end up at 4. So we know we made our full circle again. So we moved 60 minutes, which gave us 1 complete hour. So back to our time tracker, we're going to write 4 o'clock because that is the time we are at now. So we went from 3 to 4, and we know from 3 to 4 is 1 complete hour, which is the same as 60 minutes. Okay, so we want to get to 5 o'clock. So we're at 4, so if we go around the clock 1 more full time, we will make it to 5 o'clock p.m. And that is at what time it ended. So we're going to go back to our time tracker, and we're going to write 5 o'clock. And over here, we're going to write end, because this is, in our question, we knew that it ended at 5 p.m. So we're to our ending point. But we know we went from 4 to 5 o'clock. So we made 1 more complete circle, which gave us another hour. So if the party started at 1:30 and ended at 5, now we have the time that passed. So we're going to add up how long the party was to figure out how long it lasted. So if we have 1 hour, 1 hour, and 1 hour, we know that we can just add our hours together. But we can't add our 30 minutes with our hours because 1 hour equals 60 minutes. And remember we said 30 minutes was half an hour. So we can't add minutes and hours together in this problem. So we have 1 hour plus 1 hour plus 1 hour, which gives us 3 hours. So we added our 3 hours together. So we're going to cross this out. And the remaining amount of time we have is 30 minutes. Well, we don't have any more minutes to add with those minutes. So we're just going to bring them down, and we're going to say 30 minutes. So we know that if the party started at 1:30 and ended at 5, we know it lasted for 3 hours and 30 minutes. And we used our Make 60 approach using our time tracker and our clock to figure that out. And that was our set model. And now we're going to look at our linear model. And we're going to use a timeline. We're going to use the same question and see if we can figure it out and get the same answer. So, looking at our problem again, it says the party starts at 1:30 p.m. and ends at 5 o'clock p.m. How long did our party last? So when we use our linear model or our timeline, where it says our starting point is at 1:30. So we're going to go to 1:30 and we're going to draw a line. I'm going to draw it all the way down and put a dot. And we know this is our starting point. So we started at 1:30. To get to our next complete hour, what is our next complete hour going to be? It's going to be 2 o'clock. And we know if we're at 1:30, to get to 2, which is our next full hour, we will only go 30 minutes. So we're going to write that up here. 30 minutes. And remember, it ended at 5, so we're going to see how long it lasted. So we're now at 2 o'clock. We can go from 2 to 3 o'clock, and that gives us 60 minutes, which equals 1 hour. Okay, well, we want to get to 5, and we're only at 3. So our next complete hour would be 4. So we're going to make the same amount jump that we did from 2 to 3 with 3 to 4. So we know from 3 o'clock to 4 o'clock, it's 60 minutes, which is 1 hour. Okay, so remember, it ended at 5, so we're at 4. To get from 4 to 5, we can make one more complete hour jump. So from 4 to 5, it is 60 minutes, which equals 1 hour. And 5 o'clock is our ending point, so we're going to put a big dot there. So we know if we started at 1:30, from 1:30 to 2, we went half an hour, which is 30 minutes. So we're going to write 30 minutes down here. 30 minutes. And then from 2 to 3 was 1 hour. 1 hour. Then from 3 to 4 was another hour. And from 4 to 5 was another hour. So right now we have how many hours? 3. So 3 hours. Now, looking back, how many minutes did we have? We only had 30 minutes. So the party lasted for 3 hours and 30 minutes. So now you know how to solve time problems with using set model, which we used our time tracker and our clock to use the make 60 approach, and we also used a timeline for our linear model.